some of these questions and work through them just to prepare you for the test and so forth. So if nobody has anything in particular, I'm gonna ask you to go to question 6. Okay. Go to question 6 on page 18 in your booklets. Yeah, that's fine, Nico. Yeah. So let's go to question 6 here. That one could be complicated because it's not something we've seen. We've seen a lot of, we clearly know A and like X and Y. This one may not be as clear, okay? So let's read it first of all, because that's going to be important for you to read. A test has 2 sections. Each question in part A takes approximately 5 minutes to answer, and it's worth 4 marks, right? While each question in part 2 takes longer, takes 10 minutes, and is worth 10 marks. Students have at most 1 hour to complete the test, and they must answer at least 7 questions. Notice that it says overall 7 questions. It doesn't say must answer at least 7 in the first part or second part. So it's a combination, okay? So let's set up our inequality, shall we? So if you have this done, you can just follow along, which is ideally what should happen, right? And so let's see what the question is asking, because that's kind of what you're going to go through anyways. Write a system of inequalities and the objective function for this problem. So notice that I jumped straight to the objective function in A already, and that shouldn't be too hard to do. Okay, so let's start with A. I will let X be question in part 1, right? And Y is going to be my questions, right? Question in part 2. Okay, so you define your variables. Because variables are, they're inherently positive, right? You can't have negative question numbers, so they're bigger than or equal to 0. Just do that right next to your definition of the variables or the introduction of variables, so you have that figured out. And let's write our system of inequalities. So I'm kind of going away from a table for some reason. When is the test of this unit? Gursahip, it's tomorrow. Yeah. Yeah, for those of you who forgot when it is, it's tomorrow. Yeah. During class time, so it's going to be right after lunch. Okay. And so here we have this. Let's start with our system. So we have, let's talk about the restriction on time, right? And this is what I always do when there's a restriction, right? Which is usually stated with at most, right? Has up to, or something like that. Those keywords has 1 hour to complete, right? And must answer at least 7 questions. So in this particular example, you have 2 inequalities. Okay, so let's go ahead and write them out. So we have 4. So we're going to talk about time. So we have 5 minutes for every question in part 1, and it takes 10 minutes for every question in part 2, and that has to be less than or equal to 60 minutes, which is 1 hour, right? Up to 1 hour of time. That takes care of that. Okay. Must answer at least 7 questions. I'm going to do that right next to here. X plus Y has to be greater than or equal to, and this is where I saw a lot of problems with the knowing which way to point your inequality. You just have to ask yourself, right? Like, what am I trying to get here? I want that to be at least 7, right? So then this has to be greater than 7, greater than or equal to 7. Okay, so make sure you have that. So inequality 1, inequality 2, done. That's it for inequalities. Objective function, where are we going to get that from? Okay, where am I going to get my objective function from? Well, the objective function in this problem, it should have been a bit more specific, but it's what is your goal to maximize your score? That is your objective, right? On any test, right? In this case, it was implicitly stated, but it is to maximize this score. So you can use capital S. Score is equal to, where are you going to get your coefficients from? Well, in part 1, each question is worth 4, and in part 2, each question is worth 10, and this is your objective function. And so write this down, okay? Make sure you have this down, or you have to have your eyes wide open, right? Like, make sure you're paying attention right now, because I will mention this. If this question had another line, right, that said, in order to pass, or you would like to score at least, 20 marks or 30 marks, they're like, wait a minute, there's a restrictions on this, on the score, then the 4 and the 10, which are they're attached to marks, right? That tells you how many marks. Then the 4x plus 10y would have had to be greater than or equal to whatever that score is, the minimum score you need to have, right? So it would have then also been part of your inequality, as well as the objective function. I will normally bring up the objective function later on after you've graphed it. I will say, okay, write the objective function that would tell us the score, like your score, how much you've scored. Or I would say, write the objective function that would maximize your profits, or write the objective function that would minimize your cost or give you your cost. So then you have to just go up and see where are the coefficients that I need for that if it's not given in the actual question. So I will be pretty specific as to what the objective function is supposed to do, okay? Because this one is for the score. If you had an objective function on time, right? Objective for time spent. If the question said, hey, write the objective function that would tell you the time that you spent on this, on the writing the test, well, then you would write time is equal to, and notice that 5 and 10, 5 minutes and 10 minutes, those are the coefficients that go in front of x and y, right? So it would be 5x plus 10y, okay? So in this case, this question wasn't very specific as to what the objective function was supposed to do. But for score, it would look like this. For time spent, it would look like that, okay? So there it is. Just put this, an aside. This is an extension. Okay. So B. It seems like my computer is muted because I cannot hear when somebody's typing. So you gotta kind of maybe try raising your hand or something. So A is done. B, it says assume all questions are answered correctly. How many questions should a student answer from each section to obtain a maximum score? Sorry, I'm kind of blocking that. how many questions should a student answer? And again, the question goes straight to the punchline, right? So first, right, you need to graph and find solution region. That's the first thing you need to do, right? And from the solution region, we're going to take the corner points, and it's going to be one of those corner points that is going to answer the ultimate question, right? It's going to that we're going to plug that into our objective function and determine which one of those combinations is the best in this case. Okay, so let's go ahead and graph this. It wouldn't take long. So first and then second, enter CPs into objective function, right? That's our game plan here. Okay, so let's go ahead and do that. If you already did it, that's good. I'm just checking something here. Okay, sorry, that was semi-important, was my wife. Anyways, let's keep going. We'll do the first one here. 5x plus 10y is less than or equal to 60. Let's come up with the intercepts and all of that. Word problems, you won't have to worry about flipping by dividing a negative, but if it's a non-word problem, you need to make sure you watch out for that, okay? Know your vertical lines versus horizontal lines. Some of you were mixing that up, okay? So I'm going to come up with the x-intercept and the y-intercept. This is the way to do it for graphing, okay? And so this would be 5x is equal to 60. And I don't have the key in front of me, so I just want to kind of once go through, and I'm going to do one more on the back side, go completely through everything so you know what to expect, okay? So 06, 12006, there we go. We have that figured out. I rewrite it quickly. And notice how you should be, if you've practiced this, you should be pretty quick. So this is solid, of course. True is below, right? When it's less than, then you determine true is below, so shade. Just tell yourself where to shade. We're going to do the reverse, right? True is below, shade above. X plus y is greater than or equal to 7. This is just 7, 0 and 0, 7. That's all you need to do there, really. Rewriting it gives you negative x plus 7. So solid, of course. And true is above because of this. True would be above the line, so we shade below. Okay. And always keep in mind, right? If the one the first one was pointing towards the y, like y is less than, and you shade it above, this one is the opposite, then you should be shading the opposite, right? So we have that figured out. Let's graph this. Only quadrant 1, folks. Okay, if it's a word problem, no, you shouldn't be going into the negatives. Overall, I was happy with the scale. Some labeling errors, and some folks weren't labeling, right? So part 1, part 2, and I'm not going to be extremely picky, right, how detailed, but there should be units attached if there are any, but in this case, just a number of questions in part 1 and part 2. You look at your intercepts. I would strongly encourage you, especially if it's a non-contextual scenario, no word problems, plug them into your calculator and see where the points intersect, right? Because some of you were running out of room because your scale was so small, right? make sure you put the intercepts in there, right? And once you find it on your screen that the intercept is way over here, then you know that you need to account for that in your scaling, right? So I look at 12,007. Yeah. So if I go up by twos, I'm fine. 2, 4, 6, 8, 10, 12. That should do it. Same thing here. 2, 4, 6, 8, 10, 12. And I label 12, 0 and 0, 6. And don't forget the shading, right? So 7, 0, 0, 7. Right? So this line is the x plus y is greater than or equal to 7. And then this line is 5x plus 10y is less than or equal to 60. Okay, you have that. So the x plus 7, you're shading below. So I'm going to shade. And then this one you're shading above. And this is my solution. Okay, label your solution region, right? Make sure. And the corner points, we'll do this right here. Based on my solution region, it's the points that surround it, right? So this one I can read 7, 0. This one I can read is 12, 0. This one I need to find using my calculator. Can somebody, oh, I have my key here, I think, I believe so. I don't want to spend the time looking for it. So I think it's 2.5. This one is 2.5. So, and if it hadn't been rounded, you then go ahead and round. Write it the way it is as a decimal, then round. Okay. So some of you did all of those things, meaning you are doing your homework, you are reviewing, right? So there's that. So out of these 3 corner points is your, that's where you get your ultimate solution from. So we're going to plug that in. So 7, 0, plug that into our objective function for score. So it's 4 times 7. That's it. The 12, 0, you would go into the objective function, which is just 4 times 12. The other part is 0, and then you have 2, 5. Score is 4 times 2 plus 10 times 5, right? And so here you have 28, a score of 28. Here you have 48, and this would give you 50, and 8 would be 58, right? And so this is the highest maximum score. Okay, so there you have it. That's your ultimate, right? So you could have a sentence here answering 2 in part 1, sorry, and 5 in part B would maximize the score. Okay, so there you have it. That combination of questions answered would maximize. That's based on all the restrictions that are put on in place there. Okay, so that is that, and we're gonna now go to the back side to 19 and answer. We can do 7 or 8. I'll do question 7. So this was question 6. Oh, allow me to backtrack one more. If you had, pay close attention, everybody, look at the screen right now, okay? Let's say for whatever reason it said it gave you a vertical line or a horizontal line. So let's say the vertical line resulted from it saying that you need to score at least 5 questions from part 1, right? That would be a vertical line. That would mean that if this is 4 and that's 6, so 5, you would have a vertical line right there, right here. Now you actually have 4 corner points because it's where lines meet, right? So it would be here, here, right? These two, this one and this one. At least 5 means that right is true, so you'd have to shade the left side. So your solution area, your solution polygon would look different. Okay. Same thing here. If you have a horizontal line, you need to score at least, you need to answer at least 3 type part 2 questions. You would have a horizontal line there. And so then you have 1, 2, 3 corner points surrounding that little triangle, right? So you have to kind of think about, like, where is this going? What is my solution region going to look like? And go from there. Okay. Don't just blindly write down corner points that contradict what you just graphed, right? So you got to watch out for that. Okay, so let's go question 7 here. Let's read it together. You read it. I want you to come up with a system of inequalities here after reading it. Do it on scrap paper. I'll be right back, okay? Driver wants to maximize the distance traveled using at most 96 liters of fuel. So the sentence starts with an inequality right there, okay? If it said that has up to or at most 96 liters of fuel, you know that it's an inequality right there, right? Inequality 1, for instance. When the car travels 100 kilometers an hour, it uses 12 liters of gas per hour. When it travels at 90 kilometers an hour, it uses 8 liters of gas per hour. Those are just facts, okay? The consumption at each speed. The total traveling time must not be more than 10 hours. Okay, time must not be more than 10 hours. That is an inequality. So you know, no matter what, right? You now know you have 2 inequalities happening here. Okay. Suppose that X represents the number of hours spent traveling at 100 kilometers an hour and Y represents the number of hours spent at 90 kilometers an hour. Write a system of inequalities that represent the constraints, the restrictions, right? That's the same thing. Okay. Write a system that represents the restrictions. So we have that, and we'll go ahead and do that. So I'm just going to write down X is it says the hours spent, hours at 100 kilometers an hour, and Y is represents the hours at 90 kilometers an hour. And we know that X and Y, it's time, right? You can't have negatives. And this is actually continuous. So that means that you don't have to round because hours, it's time, right? And we're not talking about time a plumber comes to your house, right? That would be half-hour increments or full-hour increments. We're talking, time spent driving, so you can have decimals, portions of an hour, okay? So let's go ahead and write our inequality, okay? See if you got there. So the first one, you have at most 96 liters of fuel. That's where the right? The amount of fuel, it says 12 liters when you drive 100 kilometers an hour for the time, right? And you use 8 liters when you drive at 90 clicks an hour. So that means that 12 liters at, hours spent driving 100 clicks an hour and 8 liters time spent at 90 clicks an hour, that combination cannot be greater than, what does it say here, 96 liters, right? Because that's the capacity you have, right? And it's all in liters, so we're good up to 96 liters of fuel. So it doesn't matter, you can drive at different speeds for different lengths of time. The last straw, right? The restriction is that you cannot use more than 96 liters of fuel. It's perhaps the fuel capacity, right? And the total traveling time must not be 10 hours, must not be more than 10 hours. So that means that you have x plus y, like the hours spent at different speeds cannot be more than 10. So also less than or equal to 10. So it's pointing the same way as the one before. Okay. Up to 10 hours driving. Okay. Now let's see here. Could you have thrown in another? They might have said because the road that you're traveling on, right? Part way through there's like a construction zone, so you have to guaranteed for 2 hours drive at 90 kilometers an hour. You can't drive 100 because it's a construction zone. You have to slow down. So then it would have been, oh, okay, there's X, the number of hours at 90 kilometers is at least 2. So then you would have had a Y, right, is greater than or equal to 2 in here. They would have added that in the mix, right, specifically towards one variable. So you gotta kind of just make sure you are aware of how many inequalities show up, look for keywords, and then you go from there. So two inequalities, that's all you need. Graph your inequalities and determine the solution region. So let's go ahead and do that. This shouldn't take long at all. So I will just label this 1 and 2, right? For the first one, the x-intercept and the y-intercept are as follows. The x-intercept is when y is equal to 0, so you have 12x is equal to 96. Divide both by 12. X is equal to 8, so that's 8, 0. Nice round numbers, we like that. 8y is equal to 96. Divide both by 8. Y is equal to 1, that's 12, so 0, 12. You wrote your intercepts, rewrite it right away. 8y is less than or equal to negative 12x plus 96. Divide everything by 8. Y is less than or equal to negative, just leave it like that, right? If you're not sure, plus 12. So we will shade true region is below, we're going to shade above, right? We're doing the opposite because we want to do reverse shading when it's a system, okay? For the second one, it's 10, 0 and 0, 10, done. Rewriting it as a breeze, okay? We will shade true is below, so we will shade above. So both of them are being shaded above. Let's go ahead and graph it. So the test will incrementally go towards objective function. So you might at first just have, just write a bunch of inequalities, read and write the inequalities. And because you're only writing the inequalities, I can have a bunch of restrictions appear in that word problem. Then it will move on to, okay, this is a word problem, write the system, graph it, state the corner points, right? And then the last question will most likely be something that has an objective function to it, right? And so that's the progression, like no word problems, just writing the inequalities, then a word problem where you have to actually also graph those, and then another one where you have to do writing inequalities, graphing, and objective function, the whole 9 yards, okay? And then there will be one of the 4 types, the quadratics on the test as well. So review those, right? The regression question. And I also, if you did those worksheets, there were a number of questions that would have, reviewed that. Okay, so let's go ahead here, and this is hours at 100 kilometers an hour, hours at 90 kilometers an hour. I look at my intercepts, if I go up by 2, that's fine. 2, 4, 6, 8, 10, 12, that's good. I'll do the same, 2, 4, 6, 8, 10, 12, that's good enough. So 8, 0 and 0, 12. And this is 12x plus 8y is less than or equal to 96. And then it's 10, 0, 0, 10. Don't get too used to it always looking, the solution regions always looking the same way. It can be anywhere. It could be here, it could be here, it could be all of this out here, it could be here, right? So it's shade above for both of them. So I'm just gonna follow one at a time, right? I shade above that one, and I also shade above this other one, just to make sure I do this right. And then just go ahead and I made a note that the graph, I'm going to try to make it where you have to get write the inequality from. I'm going to make sure that you can see the points at least. Okay, so we have solution region labeled, we have everything. Now the corner points. So the corner points, how about we state them right here? Easy one here is 0, 0, irrelevant, right? Then this one I can read, that's 10, 0. Sorry, 0, 10. See, be careful. It's 0, 10 up here. This one I'll use my calculator for. This one I can read, it's 8, 0. So using the calculator, I find that one. And I'm going to cheat here and just go and find the answer. And I believe it's 4, 6. Okay, 4, 6. All of them are round. Even if they weren't, in this case, it wouldn't be a big deal. So I'm all the way to here. This is normally where it goes pretty good. But now, the objective function, right? It says, use the objective function to determine the maximum distance the car can travel. Well, let's back up. What's the objective function here? Well, they're interested in distance. See, the objective function, and I'll back up here. Watch here. It's distance, right? The objective function for distance is, I'm going to call it D, capital D. D is equal to, right? If you travel 1 hour at 100 kilometers an hour, you'll cover 100 kilometers, right? That's just as simple as that. And for every hour you spend at 90, you actually cover a distance of 90 kilometers. So this is the objective function that kind of just creeped up here. You're like, what, right? Like, where'd that come from? That's just it. It's kind of like in the units in this case, right? So then you plug them in. Distance, if you drive 0 and 0, it's just 0 kilometers. If you drive 0 at 100 kilometers and 10 at 90, that would just be 90 times 10, which is 900 kilometers. Then you have 10 times 4, 100 times 4, sorry, and 90 times 6. And last but not least, you have 100 times 8. That would just be 800 kilometers. And then you have 400 and 540, that is 940 kilometers. So this is the maximum distance. Traveling 4 hours at 100 kilometers an hour and 6 at 90 kilometers an hour will do the trick. Okay. I think if you're writing this down, go for it. And I will just see if I need to use one of these here. I think that's it. I wouldn't mind doing the wedding planner question on page 21. Let's go for it. Again, ideally, you already worked through at least the questions that we did, that I went over just now. And then ideally, you still want to give this one a go, okay? And you know what? I'm curious. I will. Let's define the variables, right? And then I wouldn't mind you submitting. We'll enter it in the chat, right? What your system of inequalities would look like. Okay. So don't finish this question, and then I will probably dismiss you. Just maybe just go through the things that you're supposed to know to prepare for the test. Okay. A wedding planner is choosing two types of vases, right? So small and large. So you have, that's your X and that's your Y right there. Small vase can have 5 flowers, while large will have 7. Okay, so there's the amount of flowers. It's like a fact. There's no inequality yet stated. She has up to 70 flowers to place over 12 tables. Okay, so that one is a little tricky here. Up to 70 flowers, so we know for sure that is an inequality right there. Okay. What about the over 12 tables? We'll have to figure that out. Okay. Each table must have at least, right? Each table must have at least one flower arrangement. Okay. So there you have that. Define variables and state the implicit constraint. So we'll do that here. We'll let x be the number of small vases. Y is going to be the number of large vases there. And implicit constraint, we're going to take care of that. And we definitely know that this is discrete, right? It's number of items, right? So we've got A taken care of here. Write a system of inequality. So we're going to do that right next to it, right under it, I should say. So we have up to 70 flowers. So if our variables are small and large vases, right, then we're going to go 5 flowers in every small one and 7 in every large one, right? That combination, right, the number of flowers has to be less than or equal to 70 because you have up to 70, right? So you have to come down and don't worry about that AC that I just posted. I will explain that in a bit. It will not be for marks. I had it originally, but I'm just gonna ask you to maybe give that one a go to prepare for the test. So I'll release the key a little later. Okay, let's finish this one. And the other one is saying that at least this is an inequality right there. At least one flower arrangement per table. Okay, so how would you transfer that into an inequality? Okay, well, if every table has to have at least one flower arrangement, right? That means that the number of small and large, right, has to be greater than or equal to 10. 12, sorry, not 10. I don't know why I came up with 10. But there are 12, right? There are 12 tables, and each table must have at least one. So that means that, right, the number of flower arrangements has to be 12 or more, right? Because if you were to just go with one in each, then you have 12. But if you chose to go with a small and a large everywhere, right, then you would have more than 12. Or perhaps some tables could have 2 and others 1, right, depending on your setup. So that's that, right? That's what I was trying to say here, in a very sneaky way, right? So you have your inequalities, only 2. There could be a third one, but we don't see it, right? If it said there has to be at least, 5 or half of the table, so 6 large flower arrangements, there has to be at least 6. Then, y would be greater than or equal to 6, right? That would be a third one added to the mix. So there could be a cost element to this right from the beginning, and then saying that you know the budget or the maximum somebody wants to spend is a certain amount of money, then there will be another inequality in the mix, right? So keep thinking and keep going through it and see what you came up with. Okay. All right. So C, graph the inequality, state the corner points around if necessary. So let's go ahead and do that. We have 5x plus 7y is less than or equal to 70. Come up with the x and the y-intercept. 5x is equal to 70. Divide everything by 5. That's 20. No, 114. So 14, 0. No. Yeah, that's right. 14, 0, sorry. And then 7y is equal to 70. Divide everything by 7. Y is equal to 10. So it's 0, 10. So again, nice round numbers. Not always going to be the case. Don't panic if it's not the case. Okay, so just keep them as they are for your intercepts because they're for graphing purposes. Okay, it's the corner points you want to round. Divide everything by 7. y is less than or equal to negative 5 over 7x plus 10. That goes into your calculator later, and we're going to shade below is true, so we shade above. Okay, let's do the other one. That one is just 12, 0, 0, 12, and it's y is greater than or equal to negative x plus 12. So we're going to shade below because above is true. Okay, let's come up with number of small process, number of large, and I'm looking at my numbers, and again 14, 0, so 2, 4, 6, 8, 10, 12, 14, 16. I have enough to make this work. I'm going to go up to 12 here, 2, 4, 6, 8, 10, 12, 14 for good measure. There is your graph. So we've got 14, 0, 0, 10. Use a straight edge, right? And we have 12, 0, 0, 12. Intersect. So this is x plus y is greater than or equal to 12. And this line is 5x plus 7y is less than or equal to 70. So careful, you're going to do below on this one. So I'm following it, I'm going below, and it's above for the other one. So that leaves me with this sliver here. That's my solution. I'm going to come up with the corner points. I've got 12, 0 and 14, 0. And this intersection here, I guess it would have been in the key, right?